Welcome back. Now in this video I will make a line follower robot which includes the following features. It will follow a line, it will avoid obstacles, we will log the data into SD card, and then we will control the speed using PWM, and then we are going to use voltage and current sensors to measure the voltage and currents of the motors, and then we are going to display it on LCD, and after that we are going to calculate the distance traveled by the robot using the encoders. So this is the list of all the sensors and modules that we have used in our project. So the very first sensor is the IR sensor module, which we have used. Basically we have used 6 of them for the line following. We have placed them right at the front of the robot in a line, and these sensors are basically working on the principle of infrared light emitting and then emitting through this LED, and this LED receives the pulse that was emitted through this after the reflection. So on a black line the infrared light is not reflected, so we get 1 at the output on this pin, and if there is a white surface then we get a 0 at the output. Basically it works the opposite. So here is a potentiometer to set the range of this IR sensor. So this is used for line following, and after that we have this ultrasonic sensor module. So in this case we have a transmitter and a receiver. So it basically works on the principle of an ultrasonic wave that goes and then reflects back, and then the receiver receives it, and the time, speed and the speed of sound, we use it to calculate the distance between the obstacle and the robot. So we have placed it right at the front of our robot, where we will use it to detect the obstacle and its distance from the robot. So this is the VCC pin, this is the ground, the trigger and the echo. Trigger is the pin where we give an impulse, and the echo is where we receive the output, and this is the 4 megahertz crystal which is used to produce an ultrasonic sound. This is the SD card module. Here we plug in our SD card, and these are the pins where one is the VCC and ground. MISO and MOSI pin are basically the master in, slave out, and this is the master out, slave in, and this is the slave clock, and this is the chip select pin. So basically we use SPI protocol to communicate with our SD card using this SD card module, and there are pins specified for this MISO, MOSI, SCK and CS. So on Arduino at Mega 2560 we have the pin numbers 50, 51, 52 and 53 specified for this module. After that we have this infrared speed sensor module, where we put it right next to our tires, where we have a disc rotating along with the tires, and in that disc we have a certain amount of gaps. This here, one side emits a light and the other receives it, while that disc rotates in between this area, which basically gives us pulses. These pulses are used to record the speed of robot. After that we have our LCD display, which is a 16x2 LCD display, on which we will show our output data, our voltage, current output, and also the where is the robot going. I mean, it's turning right, left, or it's going straight. After that we have our voltage sensor. This voltage sensor is basically has a signal, a plus and minus. The plus and minus are basically the VCC and ground, and the signal is basically used to give us the output, which is in the form of voltage. Here we put our the two connections, the two nodes where we have to check the voltage. So basically we will connect it right parallel to the output where we are connecting our motors. After that we have current sensor, which we will connect in series with the motors to see how much current is flowing through them. And after that we have this L298 motor driver module, where we have these two output which are connected to the right and left motor. Here we have a 5-volt jumper. This is the input 1 2 3 4 where we will connect our Arduino output pins, and after that enable A, enable B are used to control the speed of robot using PWM. Here we are going to give a VS which is 6 to 12 volt, and here is a ground. So this is all about our sensors. And this is the code for our line follower robot. So here first we have to include the headers, necessary header files. So first we have included the LCD liquid crystal header file, which is basically the header file for our LCD display. This header file is for SD card, and this is for serial communication for the SD card module. Then we configured our LCD display. These are all the pins like RS enable and 4 data pins. After that we have set the contrast pin for LCD, which is a pin number 6. Then this current pin A0 is basically the pin for current sensor, the output that we will get from the current sensor. Then we have set the sensitivity, which is equal to 66. I don't remember which why are we using this pin. I think I'll get it in the code. So this is the ADC value which we will use for the analog to digital converter. This is basically for the voltage sensor. So we have set the offset voltage to 2500, and then again ADC voltage to 0, then current value to 0. This is the function void check speed. So these are basically definitions of function. The functions are defined at the end of this code. Voltage sensor is defined as pin A1 and pin A0, current pin as. So here you can see this is a voltage sensor which is connected to A1, and this is a current sensor connected to A0. So after that we have created a file, my file, for the SD card. Then pin CS is basically for the chip select pin of the SD card module, and I don't remember this pin. These two resistances, float R1 and R2, are basically to define the internal resistances. After that we have defined the echo pin as 43 pin and trigger pin as 38. So basically these names are given to these pins for the basically for the ultrasonic sensor. So this is the speed, V speed, I mean like full speed of the robot, and the turn speed. So we can decrease and increase this pin, and I will tell you how can we speed control using this number. So these connections are for the motor driver. All these pins are assigned like 4 in 1 and 2 in 3 and 4, and the motor A speed and motor B speed are basically the PWM pins on the Arduino. PWM pins are basically used to control the motor speed using pulse width modulation. So we have used port B for it, pin 7 and 8, and then we have these 6 infrared sensors. I already described these pins that are attached, this pin that the sensors are attached to. After that we have these two encoders connected to A13 and A14, Here you can see this encoder. You can see this is the encoder 1, which is connected to A13. After that we have the start time, end time, which is basically for the encoder, and these are the steps. Each step is basically one small rotation of the wheel, and 20 rotations make a complete cycle. After that we have this void setup, which will run only once. Now we are defining the pin mode. We are defining all these pins as output, which are basically for the motors, the 4 inputs of the 298 motor driver. After that we are taking inputs from after that we are taking inputs from all the 6 sensors, so we are using those pins as input pins. Then we have the contrast pin as output. Analog write is basically used to write something like a PWM value, like it will be an average voltage value and whose maximum value will be 255. So this is not full like 5 voltage, but it's going to be 5 voltage but in small steps, like it will be in the form of small pulses. Then we have used trigger pin as output, where we are going to send a small pulse for the ultrasonic sensor, and then the receiver, which is the echo pin, which will receive it, which is the input pin. After that we are activating the input pull up, so that means normally sensor 1 and sensor 2 will be are going to be high. So sensor 1 and 2 were basically the right and left encoders. Then we have used the LCD header file, where we have used lcd.begin, then we started serial.begin to start the communication, and then we set the baud rate 9600. Then we gave a 200 millisecond delay. After that we have begin the the SD card using the SD card header file. Then we enter the loop, which is going to execute continuously. And in the loop, this all is basically for the SD card. So basically we are going to open a file latest.txt, a text file, in which we are going to write if the RPS, revolution per second, 2 means the right tire is greater than the left tire. Then we are going to print STD on serial monitor, just to see if there is something printing on in the SD card, if we are writing something in the SD card. Then we are going to print right turning in it. Okay, it basically means that the left tire is revolving faster than the right one, so the report is going to turn right. I said opposite. Basically the right tire is moving faster than the left tire, so it is turning right. No, the left is turning faster than the right tire, so it is turning right. And the opposite case of this is the car turning left. And for going straight, I have put these 3 conditions, where if both the tires are moving at the same speed, and both of them are not equal to 0, because if the robot is stationary, even then they both are equal, so we will get the going straight, but it's basically not going straight, it's just standing. After that we will close the file. So file is open, it has wrote something in it, and then the file has closed. Now we have wrote low at the trigger pin, then we have given a 2 microsecond delay, then we gave high on the trigger pin, then we gave a 10 microsecond delay, which means the trigger pin will get a 5 volt value for 10 microseconds, which will emit a pulse of ultrasonic wave, and then we will write low into it. So a 10 microsecond pulse has been given to the trigger pin, which will give us a sound wave for 10 microseconds, which will then go and reflect back, and then we will get input pulse in the form of pulse at the echo pin. And then we are going to convert it by simply using the speed of sound formula, and we will get the distance. Here we are just going to print distance on serial monitor. After that we are reading the 6 sensor states. So here is the basically first what we call a truth table. Like this is the truth table of all the 6 sensors, all their combinations basically. So this combination is basically 0 0 0 0 0 1, which means only the right sensor is giving us one value, which means the line is moving towards the right side and we have to turn right. For this we are giving high to the left motor, high low, which means the left motor has to turn in the forward direction and the right motor is going to shut down. And analog right, which is basically used to control the motor speed. So we can simply control motor speed by simply giving a value between 0 and 255, any value. So it will decrease and increase the duty cycle of our PWM wave. So here we are giving full speed. So here we have another case scenario in which we get a 1 1 0 0 0 0 1 1. It means the right two sensors are on. Again we are going to turn right at this stage. Here we have 1 over there, 0 0 0 1 0. So here we are going to again turn right. So these are all the possible combinations, turning right, and for the turning left we have these combinations in which the left sensors are going to be high. So we have used else if statements for all these combinations. Now if all of the sensors are low, it means all sensors are off, which means we are basically on a T. It means a black horizontal line. So there at that stage we have to stop. We are giving low at all the motor outputs. And also if all of them are high, which means white floor, even then we do not want the robot to move because there is no line. So again we are stopping a robot at that point. Now moving on next to here. Now it is about the distance. If the distance is between 4 centimeter obstacle distance, then we are simply going to write sensor to state is equals to low. Then we are simply going to rotate the robot in by moving both the tires in opposite directions, like motor A1 high low and first motor high low and second motor low high. So both the tires will rotate in the opposite direction, which will turn the robot in 180 degrees until we get low from right sensor 2. So basically the robot is going to move left, rotate left until we get back on the black line. So this is what this loop is doing. If we get an obstacle, we are going to move until we get back on the line, which will turn the robot 180 degrees back. After that, to measure the current, we are using analog read. The output from the current sensor is going to be analog input, so we will use an ADC to convert that, and then the current value will be shown on the serial monitor. So basically the current value and voltage value both are being shown over here. After that, basically we are going to print it on the LCD too, and also the serial monitor. No, it's only the serial monitor. So after that we will clear the LCD, then we will set the LCD cursor, then we will print current value, and then we are going to again set the cursor at the 6th bit of and the 6th column of 0th row within the first row, and then we are going to print milliamperes, and then again we are going to print the voltage value on the LCD. Now this function void check speed is used to check the speed of robot. Here we are going to start time millis, and we are going to end time, which will basically where we are using 1 second. We are going to get the revolution per second, so we are going to use this timer for 1 second. So here until the time ends, if digital read sensor 1, if this value comes to 1, then the step will increase left, and the step 1 will increase, which is basically the movement of the right tire, and we are going to read digital sensor 1 until it gets to 0. So whenever 1 comes, step 1 increase, then we will move on to get out of the loop, and if it stays there, then it will stuck at here. So if it moves, then we'll get out of the loop, and if the get a 1 on sensor on the other sensor, which is basically the encoder, we will increase the step 2 by 1. So this is how this encoder is working. Both the encoders, left encoder and right encoders, are working. Now in the temp we are going to store the steps 1 minus steps 1 old. So revolution per second is basically counted as temp 1 divided by 220. 20 is basically the number of steps required to complete one revolution. So we divide temp 1 by 20, so we get the revolution per second of the right tire, and RPS 20 for temp 2. So we are printing it on the serial monitor. So that is how our code is working. This is all. Now we are moving on to the Proteus implementation of our project, and here we have this our Arduino Mega 2560, and here are all the ports that we have connected. We have used this default pin so to get rid of wires. So first of all, we have this 6 IR sensors connected, and we have used serial connectors for each and every sensor, for each and everything. First we did verify everything. After that, after the verification, we use serial connectors to make the PCB layout. So here are the 6 IR sensors which are connected to the port number 23, 25 and so on. And here we have our voltage and current sensor, 3 serial connectors for both of them, and 6 serial connectors for motor driver, and they are all connected to the Arduino Mega 2560. These serial connectors are extra alongside the Arduino. So basically when we put on the Arduino, which we will attach on the bottom copper, we have these extra serial connectors attached to all these ports, so we can use them easily. So for encoder we have used these serial connector, ultrasonic sensor, SD card module, all of them are used. We have used serial connectors. And for the PCB layout, here we have the PCB layout. So basically it's upside down. Now here it is. You can see here we have this footprint of our Arduino Mega 2560. Here we will place our Arduino, which is basically on the bottom copper. So here we are going to attach our Arduino at the bottom copper using male cell headers, and the other components are going to be placed on the top copper, except for the IR sensors. 6 IR sensors, and this Arduino are going to be attached to the bottom copper. So this is the front of the robot, where we have attached these 6 IR sensors, which are being used to follow the line. And here we have our ultrasonic sensor right at the front to detect an obstacle. Here this is the LCD display which we have placed at the back of the robot. Here we have the 2 encoders on the right and left, and if we want to track anything, any port, if we are finding it difficult, we don't know where does this belong, we can simply right click on it and then we can click on show in schematic. So here you can see this is an Arduino cell, which is a separate cell just in case we need to use these pins of Arduino. We do not need to unplug the Arduino, we can simply drill a hole through these and we can simply make our connections. So these green lines that you see are basically connected because when I used these square through hole pad, when I replaced them, like I simply adjusted them, these lines did appear. So there is nothing to be worried about these lines, they are all connected. And here it's our team name. These are both the encoders. These are the extra ports that we have connected, and if here I have attached the power supply. These are for the power supply if you want to attach any. Here we have the motor driver. It will be on the top copper, so you don't need to worry about the Arduino. It is going to be at the bottom copper. The current sensor, voltage sensor, and here we have the SD card module, which is connected to the pin 50, 51, 52 and 53. And to make the soldering easier for us, I just made these holes bigger by using the square hole pad. And also we have used some jumper wires too. So this is all from our PCB layout. So this is our robot. Here we have the 6 sensors and ultrasonic sensor at the front and all other modules at the top. This is our name, group name, MacTech, and here we have opened the serial monitor to show the output, and then this is our LCD display, and here at the bottom we have the encoders and the alternate motor driver. So now we are going to check one of the logics. Here you can see it is stop, so we can see the robot is in the stop state. Now the black line is at the left, so it is going to turn. It is going to turn right. Black line is at the right, so here you can see it is written turning right, so the robot is turning right. So here we have proved our one of the logics. And now we can prove another logic where the robot is going to turn right, where the robot is going to turn left, and you can see it is written turning left, and the robot is turning left. So this is also being printed in the text file that we have in the SD card. So this is the practical implementation of our line following robot. It is following a black line. Now after detecting an obstacle, it is turning in 360 degrees, and again when it detects a line, it again starts to follow the line. So here you can see we have our robot following the line. So that was all from today's video.